Okay, today's section 36. We're going to be graphing inequalities. What's an inequality? Not equal. Yep. We're going to be having things like greater than, or less than, or greater than equal to, or less than equal to. So, our first equation or inequality is y less than negative 2/3 x plus 4. You first want to say, what kind of graph is that going to make? What kind of equation is that? It's linear. How do we know it's linear? It's not squared. Well, that's not how we know it's linear. That's not how, that's what my other class is too. That's not how we know it's linear, but we know it's not quadratic. So I guess that's a good guess.
Oh, because it's a constant rate of change.
Yeah, because it has the slope. Really, the definition for linear is that your variables are just to the first power. So both x and y are to the first power. That's linear. So quadratic would be either x or y was to the second power. Cubic would be to the third power. Quartic would be the fourth power. So this is linear because they're just in the first power, and because it is in the form of y equals mx plus b, I'm going to graph it by using my y-intercept and my slope. So what is my y-intercept? 4. So 0, 4, I'm going to plot a point. And then from there, I'm going to use my slope, which remember is rise over run. What is my slope? It's negative 2/3. So from 4, we're going to go down 2 over 3. Down 2 over 3. Or up to left 3. Before you use that to connect it, these are not equals. So there's something extra you have to think about. You did this in Algebra 1, I know you did. So what you have to think about when you go to connect these is if this is going to be a dash or a solid line. So this is not equal. It's only less than. It's not equal. So am I going to have a line or am I going to have a dash line? That's not really there. Dash line. This one's going to be a dashed line because it's not equal. If it were less than or equal to, then it could be equal and then we'd have a line there. This one's not equal, just a dashed line. Anybody remember something else we have to do about these when they're inequalities? What? We have to shade it, yeah. So it's either shaded it's going to be shaded on either side of the plane. This is kind of dividing the plane into two sides. You have to figure out which side gets shaded. And I do not like saying, oh, well, it's less than, so it's below. Because that may work sometimes. But it does not work every time. So I'm going to give you a method that works every time. In order to know which side is the solution, you're going to test the point. So we're going to test one point that is on either side of this line. Do not test a point on the line. So I need somebody's suggestion, make it a good one, to test what point. Because we're going to have to plug it in and plug it into the equation. So give me a good one. 0, 0. That is an excellent one. That's totally the one I would have picked. Okay, you can do that one. You can do that one. I'm going to do 0, 0. And 0, 0 is not on the line. It is on this side of the line. So we're going to see if it is a solution or not. So we test 0, 0 into the equation. We put it in y, so 0, less than negative 2/3 times x, so 0, plus 4. And we simplify that. We get 0 is less than 4. And we say, is that a solution? Is 0, 0 true in that equation? Inequality. 0, 0 is less than 4, so true, it is a solution. So 0, 0 gets shaded. Done. What? What'd she say? What's going on?
I'm kind of a person that I forgot how you say it. I just wanted to let.
Oh, yeah, yeah. So when you read it, like left to right, if it comes to the small side first, it'll be less than. Yeah. Or this one over here. That's not a dumb question. I have so many people still not remember. Yeah, it happens all the time. So you read left to right, if you come to the big side first, it's greater than. So the next one is y is greater than or equal to 3x. So how do we graph this? What kind of line or parabola or absolute value? What is this? Circle? Is this a line? It's a line. I don't think it's a triangle. I gave you circles in today's assignment. That's why I asked. Oh my gosh, they're the easiest things to graph. We'll get them. Okay, you guys are graph a circle. Didn't you do that in geometry?
I don't remember.
Okay. What is our y-intercept? Our b? What's our y-intercept? 0, 0. Okay. Plot that. And what's our slope? 3 over 1, so we go up 3 over 1, up 3 over 1, or down 3 left, down 3 left. And some of you already said this, but let's say it again. Since it's greater than or equal to, this is what kind of a line? Solid line. Now we have to test a point. What point would you like to test? 0, 1, 1, 1? Either of those is fine. I'm just going to test 1, 1. I don't know. You can test whatever point you want as long as it's not on the line. You can't test 0, 0 this time. So I'm going to test 1, 1. I'll plug in 1 for y, plug in 1 for x, and I'll get 1 is greater than or equal to 3. Is that true? No, that is false. So I'm not going to graph the side of, I'm going to shade the side that has 1, 1. I'm going to shade the other side of the line. Because 1, 1 is not a solution. So if you're ready to go on, turn your paper over. So I know that we're ready to go on. If you're ready, then I can go on. This next portion is just like how to graph a quadratic inequality, which we're about to do. This tells you how. I'm going to just do the steps with you, but if you forget, you could go read it. Notice it says that's the point, so we are still doing that. So example 1, we're going to graph y is less than negative x squared minus 2x minus 1. And I'm going to say, other than pulling out our calculators, how could we graph this by hand? What could we do? Was in your assignment yesterday. Ellie? On the axis of symmetry and the vertex? Okay. So since it's in the standard form, we'll do AOS is x equals negative b over 2a. So we'll do negative 2 over 2 times negative 1. So that gives us x equals negative 1. Axis of symmetry. How do you find our vertex? How do we find our vertex? Plug that in. Yeah. So I'm going to do negative times negative 1 squared minus 2 times negative 1 minus 1. And I'm going to simplify it. So we're going to get negative 1 plus 2 minus 1. 0. Vertex is at -1, 0. What else can I find so I can graph this? Think about all the things we've studied recently. What else can we find? By the way, graphing's not going away. Like, you're going to do it the rest of this year and next year, no matter what course you go into. There's more graphing. This is not something you're going to avoid. This is like the first thing we started out doing here. It's going to continue. So what else can we find besides the vertex in an axis of symmetry? X and Y intercepts. What do you want to find next? Y intercepts. Okay. So we find our Y intercept. So I'm making x 0. So -0 squared minus 2 times 0 minus 1. 0, -1. We look at the graph. Is there something else I could graph now? The reflection point, the mirror point, yeah. Can I find the x-intercepts? Child? Why? What? So can I find the one x-intercept? Oh, I already know, but I didn't call it an x-intercept. What did I call it? The vertex. So that I've already found. So how else are we going to find more points? You can just plug stuff in, or does this have a stretch? It has a reflection, but it doesn't have a stretch. So this is just a parent function flipped over. So we have that out 1, down 1, out 2, down 4, out 3, down 9, but I'm off the graph. So parent function is flipped over. Or you just plug in points and find the points. Is this going to be a dash or a solid? Huh? Dashed or solid? David, dashed or solid? Dashed. Because it's not equal to. It's only less than, so it's dashed. It's not really there. And then we have to figure out what side of this parabola is shade. So we got to test the point. Any ideas? Suggestions, I should say? Sure, 0, 0 is not on the parabola, so I can test 0, 0. We'll plug that into the original question. 0 less than -0 squared minus 2 times 0 minus 1. Is 0 less than -1? So does 0, 0 get shaded? So where do I shade? Inside your parabola, right? Please don't shade so crazy dark that I can't see that it's dashed. I don't feel like you have to fill in the space completely. Waste of time. All right, example 2 now is more like what we're doing for our assignment, which is graphing a system of inequalities, so there's more than one. And what we're going to do is we're going to graph them, and then we're going to find where they overlap, and that's going to be the solution, is where they intersect. So when I know some of you work a little bit faster than I explain it. If you're working ahead, when you go to shade that first one, don't shade it very dark. Really light. You'll see. Okay, so the first one is y is less than -x squared plus 3. And I see that that is quadratic. How can I graph that one? I'll give you a hint. It's in vertex form. So what's a vertex? What? 0, 3. Excellent. So I have a vertex. What else do I know about this equation? It's reflecting the x-axis, so it's flipped down. What else? What's my y-intercept? Okay. There's no stretch or shrink. So what's that? Sorry, I'm taking a photograph. It's kind of like the other one where I asked about the x-intercepts and they were already gone. Because nice stretch or straight, so if I just flip it down, what do I grab? Just grab my parent function, right. Is this going to be a dashed or solid? Dashed. What ordered pair could I test? Would 0, 0 work? Okay, let's try 0, 0. 0 less than negative 0 squared plus 3. So 0 less than 3. True or false? True. So I will shade 0, 0, but I'm not going to really do it yet. I'm just going to like lightly say this is where it's going to be. That's where it's going to be. But we still have another equation to do. So second equation. Y is greater than or equal to x squared plus 2x minus 3. What can I find? I'm going to do it, but I'm going to do it a different way today. What else can I find really fast? By looking at it, what can I find? It's the easiest thing to find. Let's do it. Before that even. I'm going to do something even easier. What else can we find? AOS, vertex, what else? David? I'm going to do that. But before that. Yeah, how do I find the y-intercept? Well, 0 plus the y-intercept. -3. Okay, that I can find like really fast, even though we didn't think about it right away. Now, you all had other good suggestions, and when you do your time, you can do it however you want. I just want to show you that I'm going to do this one by factoring, because I love factoring. I'm going to do this one by factoring and doing the x-intercepts. So this one does factor pretty easily. X, and it's going to be 1 plus 1 minus. What's the plus going to be? Let's multiply together, give us 3, add to give us 2. It's going to be plus 3 minus 1. So my x-intercepts are going to be at x equals negative 3 and x equals positive 1. And if I know my x-intercepts, then how do I find my AOI? Average them, so right in the middle, looks like it's going to be x equals negative 1. And to find my vertex, I'll plug in negative 1, and you can plug it into the original question, you can plug it into the factored question, it doesn't matter which one you plug it into. And I get negative 1, negative 4. I have a mirror point for the y-intercept. So I have at least 5 points, so I've got my equation. This one is the parent function also. There's no stretch, so I could find more points if I want them. Is this going to be solid or dashed? This one's solid because it is equal to. Can I test 0, 0, my favorite one? So I'm going to plug in 0, 0, I'm going to get 0 is greater than or equal to negative 3. And that is true. So 0, 0 does get shaded. And where the two graphs overlap is my final solution. So you'll see when I have my final solution and you look at it, can you tell where the two graphs overlap? The dark section. That's why I do like the other two sections really, really light, but like focused on where they overlap. So if I can't tell the difference between your darker section and the rest of your shading, then you've got to make it lighter on the other area. So if you're using like marker, you may want to only color that last step. So I can tell where the two are really dark. All right, last one. Graph the system of inequalities consisting of y is less than or equal to negative x squared and y is greater than x squared minus 3. How can we graph y equals, or y is less than or equal to negative x squared? How do we graph that one? Pair function, flip down. Excellent. Is it dashed or solid with that equals? Solid. Can I test 0, 0? No, I cannot. I feel like testing 0, negative 1. That's what I feel like testing. So I'm going to test 0, negative 1. So I'm going to plug in negative 1 for y, plug in 0 for x. Get negative 1 is less than or equal to 0. Is that true? Yes, it is. So I would shade in here, but I'm not darkening it yet. Other equation, x squared minus 3. I'm going to go to graph x squared minus 3. X squared minus 3. Translate it, down 3. Parent function, translated, down 3. Parent function, down 3. And this one is dashed. It is not equal to. I'm going to test 0, 0. 0 greater than negative 3, that is true. So I will shade 0, 0, and where do they overlap? That gets dark. There's one more thing that I'm going to say before I hand out your assignment. I told you on your assignment I gave you circles, and apparently nobody's grabbed circles before. I thought you had in geometry. We did when I taught it, so. We did do circle equations in our notes yesterday. This is the equation of a circle. With your circles, I haven't given you any transformations. So all your circles will have a center at 0, 0. That's just because I gave you ones without transformations. The center is not part of the circle. But what is part of the circle is from the center, use your radius to find the circle. So r squared is what it's going to look like. What would my radius actually be for this equation? Would just be r. So you're going to have to look at r squared and figure out what r is, and then you just start at your center, and you just go out, up, out, down, and make your circle using your radius. It's really easy, okay? But these are inequalities, so you're going to have to figure out if it's dashed or solid, and you have to test the point to see if you can shape inside or outside the circle. Okay? So your assignment is a worksheet. I'll go ahead and pass this out, and swap them up. You're going to have some time to work on that, too.